Welcome to This Explainer. I am absolutely thrilled to guide you through today's topic. Have you ever wondered how we take messy, complicated human behavior and somehow turn it into clean, actionable data? Well, today we are building a practical researcher's toolkit to tackle that exact challenge: how to quantify abstract characteristics. It's an absolutely crucial skill, whether you're designing a survey, analyzing market trends, or honestly just trying to understand people a little bit better.
Think about it for a second. In our daily lives, we measure physical things constantly, right? If I ask you for someone's height or weight, you just grab a tape measure or a scale, use standard units, and give me a perfectly exact number. But how do you measure a feeling? How on earth do you put a hard number on someone's stress level, or accurately gauge brand loyalty, or even figure out exactly how much someone likes the taste of a new soda? Measuring these abstract constructs is a seriously complex challenge because, unlike height, we don't naturally have standard units for human opinions.
Okay, so here's our roadmap for today. First, measuring the unmeasurable. Second, the 4 levels of measurement. Third, types of scaling techniques. And finally, we'll lock it all down with reliability and validity. Let's dive right in.
Starting off with Section 1, measuring the unmeasurable. Before we can gather a single data point, we really need to get our foundational definition straight.
So what's the actual difference between measurement and scaling? Well, measurement is basically the act of assigning numbers based on pre-specified rules. It creates the structure. But remember, we aren't measuring the object itself. We're measuring a characteristic, like a feeling or an opinion. Scaling, on the other hand, acts like a translator. It takes those text statements, like qualitative opinions about customer service, and translates them into numeric values. So if a customer says they strongly agree that service was good, scaling is the rule that turns strongly agree into a number, like a 1. And that makes the data incredibly easy to organize and analyze.
Moving to Section 2, the 4 levels of measurement. Now that we know what scaling does, we need to understand the actual rulers we're using.
A brilliant way to visualize this hierarchy is through a runner analogy. Think about how numbers can act in 4 completely different ways in a race. First, the number is literally just a label on a jersey. Then, it's a rank on a podium. After that, it becomes a performance rating. And finally, it's an exact time in seconds. As we climb this measurement ladder, each step up includes all the qualities of the level below it, plus something brand new. Let's break down exactly what each of these means for our data.
At the very bottom rung, we have the nominal scale. It is the crudest form of measurement, but also the simplest. Here, numbers just identify and classify objects into distinct categories. No implied order, no mathematical value. Just like the number 7 on our runner's jersey, the number is only a label. So if you assign a 1 for male and 2 for female in a survey, it obviously doesn't mean female is twice the value of male. You're just classifying. The only statistical math you can do here is a basic frequency count to see which category has the most people.
Step up 1 rung, and we hit the ordinal scale. Now we're bringing in a logical order. We're ranking items. Think of those runners finishing first, second, and third. Or imagine a fast food shop asking you to rank their service from excellent to poor. We know that one rank is better or more than another, but, and this is key, we don't know by exactly how much. The distance between first and second place might be a fraction of a second, while the gap between second and third could be 10 whole seconds. It gives us the order, but not the magnitude of difference.
Next up is the interval scale. This is where we finally get equal numerical distances. The difference between a performance rating of 8.2 and 9.2 is the exact same distance as the difference between 9.2 and 10.2. Measuring temperature is a classic example of this. But there is a catch. An interval scale lacks a true absolute 0. 0 degrees Celsius doesn't mean there's literally no temperature, right? Because the 0 is arbitrary, you can add and subtract these numbers, but you cannot multiply them. You can't honestly say that 40 degrees is twice as hot as 20 degrees.
And finally, we reach the top of the hierarchy, the ratio scale. This includes all the properties of the interval scale, but it adds a fixed absolute 0 point. Because we have that absolute 0, we can now say with mathematical certainty that one value is a direct multiple of another. Think of our runner's exact finish time in seconds. 0 seconds means exactly 0 time. In market research, most basic counts are ratio scales. If you track the exact number of ATM customers over 3 months, you can definitively say that 200 customers is exactly twice as many as 100 customers.
All right, part 3, types of scaling techniques. We've defined our rulers, so now let's talk about how we actually deploy them in the real world. Whenever you design a questionnaire, you're faced with a core philosophical choice. Are you going to use a comparative scale or a non-comparative scale? In a comparative scale, you force the respondent to directly compare one object with another, like, do you prefer Coke or Pepsi? Simple. In a non-comparative scale, the respondent evaluates a single object completely independently, using whatever internal baseline makes sense to them, like asking someone to rate a single brand of laundry detergent entirely on its own merit.
If you go the comparative route, you've got some great tools in the toolkit, things like paired comparisons, rank ordering, or a constant sum scale. But one highly specialized, really cool method is Q-sort scaling. This is a procedure where respondents sort a large number of statements based on similarity. Instead of just checking boxes, it actually helps researchers evaluate the internal comparisons a respondent makes in their own head. It's incredibly useful for getting those deep psychological insights.
On the flip side, we have non-comparative techniques. This could be continuous rating scales, where someone just places a mark somewhere along a continuous line from one extreme to the other. Or, much more commonly, itemized rating scales. You've definitely taken these. The Likert scale asks you to indicate your level of agreement. The semantic differential scale asks you to rate a brand between bipolar adjectives like good versus bad. The key takeaway here is that the respondent is evaluating the item completely on its own.
Which brings us to our final section, reliability and validity. This is the quality assurance phase of our toolkit to ensure what we just built actually works.
Pillar number 1 of quality assurance is reliability. And reliability is all about consistency. Does your scale consistently produce the same results under similar conditions? Imagine giving a customer satisfaction survey to a group of people and then giving the exact same survey to them 2 weeks later. Assuming their underlying sentiment hasn't changed, the survey results should be really similar. If the results are wildly different, well, your scale is unreliable. It's just introducing random noise into your data.
So how do we actually put that consistency to the test? Well, we use the tools of the trade. There's the test-retest method I just mentioned. We can also use inter-rater reliability, like having 2 interviewers independently score a job candidate to make sure they're aligned. Then there's parallel forms, where you use 2 different but equivalent versions of a test. And critically, there's internal consistency, checking that all items in a survey actually measure a unified concept. We usually measure this using a statistical tool called Cronbach's alpha. And as a quick rule of thumb, you generally want to see a value above 0.7 there.
But here's the catch, and it's a big one. A scale can be perfectly reliable and still be completely useless if it lacks our second pillar, validity. Validity is the ultimate benchmark. It's the degree to which a scale accurately measures the specific concept it is actually intended to measure. It ensures your data means something. Think about it. If you are trying to test someone's emotional intelligence, but the complex wording of your survey means you're actually just testing their reading comprehension, your test is invalid. You missed the target entirely.
Validity is kind of like peeling an onion. It comes in layers. First, does it pass the eye test? That's face validity. Does it look right at a glance? But we have to dig deeper into content validity. If we build a scale to measure leadership, content validity ensures we cover decision-making, communication, and vision setting, not just a single trait. We also look at construct validity to ensure it aligns theoretically, and criterion validity to see how well our results relate to a real-world outcome.
So, the absolute crucial takeaway here is this. Highly consistent but invalid data is actually way worse than no data at all. Why? Because it leads to highly confident yet entirely flawed decisions. Think about a bathroom scale that is always exactly 50 pounds off. Is it reliable? Yes. Is it valid? Not at all. So the next time you design a survey or you're looking at some flashy data set in the news, ask yourself the most important question in research. Are they truly measuring what they think they're measuring?